Hello students, welcome to this session here by Infinity Learn by Sri Chaitanya. Today we are doing the paper solutions for the January attempt of JEE 2024. This is the paper solution for the 27 January shift 2. So let's get started with the questions. The first question says that the equation of state of a real gas is given by P plus A by V square into V minus B is equal to RT. So the van der Waals equation, where P, V and T are pressure, volume and temperature respectively. R is the gas constant. The dimensions of A by B square. So from here, first we have to try to find out what is the dimension of A and what is the dimension of B. If you look at just this part over here, then you know that A by V square should have the same dimensions as P. Only then can you add them up. So you know the dimensions of A by V square should be equal to the dimensions of P, which means the dimensions of A should be equal to PV square. Let's set that aside. That's the dimensions of A. Because only if A is PV square, the V square would cancel and then you can add two pressure terms over there. For the next part, it's even more simpler for B because you see it is a V minus B. If I remove this from here, it is V minus B is equal to RT. In that case, B should have the same dimensions as volume, otherwise they can't be added or subtracted, which makes the dimensions of B as just volume. So when you're looking for the dimensions of A by V square, A by B square, A had the dimensions of PV square, whereas B had the dimensions of volume because it's squared, so it's also V square here. The V squares cancel out, so A by P square has the dimensions of the pressure P. That is our answer for the first one. Let's try for the next question. It says a Wheatstone bridge principle is used to measure the specific resistance S1 of a given wire having length L, radius R. If X is the resistance of the wire, then the specific resistance is S1 is equal to X pi R square divided by L. If the length of the wire is doubled, then what happens to the value of the specific resistance? Now, even though they mention it as specific resistance and there's a lot of story around the Wheatstone bridge, but the thing of note to you is just this equation, where X refers to the resistance, X is the resistance, L is the length, R is the cross-sectional area. If you compare that relation with our relation for resistivity, which is rho RA by L, resistivity is RA by L, you will see that this S1, since X was the resistance, pi R square would be the cross-sectional area, length is L here. So you know that S1, the specific resistance, is in fact our resistivity. Now, according to the question, the length is doubled. We know that even if you double length, area, whatever you change, resistivity is a property of the material of the wire. So length, the dimensions have no effect on it. So even if you double the length, the resistivity, or as they're calling it here, the specific resistance, it does not change, it remains S1. So the answer for this is option D. Next question says given below are two statements. One is labeled as assertion and the other is labeled as reasoning. So the assertion statement is angular speed of the moon in its orbit about the earth is more than the angular speed of the earth in its orbit around the sun. This is a correct statement. Why? Because we know that the orbit of the moon around the earth takes 29 days, whereas that of the earth around the sun takes 365 days. So obviously the moon has a shorter time period. If it has a shorter time period, it has a higher angular velocity. So this statement is correct. Next one says the moon takes less time to move around the earth than the time taken by the earth to move around the sun. So obviously this is also correct. And this actually tells you, like I said, since the time period is different, time period is less for the moon, so the angular velocity is high. So this reasoning is actually correct for the assertion statement. So both A and R are correct and R is the correct explanation of A. So it should be option B here. Next question says that statement 1, limiting force of static friction depends on the area of contact and is independent of materials. Statement 2 says limiting force of kinetic friction is similarly independent of area of contact and depends on the materials. So both over here depends on the area and over here it is independent. So this statement is correct, this statement is incorrect. Because we know whatever is the force of friction, whether it be static or kinetic, it does not depend on the area in contact. It just depends on the materials, which will give rise to the coefficient of friction. So the first statement, which says that it depends on the area, is incorrect. The second one, which says that it is independent of area but depends on the materials, is correct. So statement 1 is incorrect and statement 2 is correct. So it is option B over here for us. Next up, we have the truth table of the following given circuit. Now some students might be able to identify that directly as the XOR circuit. You can directly identify it as the XOR circuit, the exclusive OR circuit. If you don't want to go by that method, you can even write out what its Boolean relation is. So over here you get an A coming in and a B naught comes in over here. So what comes out is A B bar. Whereas for the second AND gate, you have A coming through a naught. So an A bar comes in here and a B goes straight forward. So we get A bar B. Both of them pass through an OR gate to get Y is equal to A B bar plus B A bar. So if you remember that this is an exclusive OR gate, if you want to create a truth table, let's check it. Suppose if A is 0 and B is 0. If A is 0, B is 0, then it is going to be 0 into 1, because if B is 0, B bar would be 1. 0 into 1 plus 0 into 1, so it is going to be 0. So at 0, 0, it should be 0. So that immediately eliminates this option and this option. Because at 0, 0, your output should also have been 0. Next, if A is 1 and B is 0, if A is 1 and B is 0, you would have 1 into 1, because B bar would then be 1. 1 into 1, that is 1. And here you have 0 into 0. So you will get an output of 1. So at 1, 0, 1, 0, you should be having equal to 1. 1, 0, you should have having equal to 1. So directly we see that happens in this case. So this is, if you identify this is an XOR gate, and if you remember the truth table of XOR gate, you could directly identify this as well. Fine. Next question we have says a current of 200 microampere deflects the coil of a moving coil galvanometer through 60 degree. The current to cause a deflection through pi by 10 radians is how much? Now we know in a moving coil galvanometer, the current or theta is equal to C into I, or I is equal to C theta, which essentially tells you that the angle of deflection is proportional to the current. That makes I1 by I2 is equal to theta 1 by theta 2. The current in the beginning case is 200 microampere. 200 by I2 is equal to, since the answers are also given in microampere, so I don't bother with the microampere here. I don't bother with the 10 to the power minus 6. The angle then was 60 degree. Since the other one is given in terms of radians, we write 60 degree as pi by 3. Divided by theta 2 is pi by 10. Pi's go away. Remove one of them here. So I2 is equal to 3 into 20, that is 60. So the answer is 60 microampere for this question. Moving on, students, if you need a little more time, you can always see this as a recording, come back and go through it. Let's move on to the next one. It says the atomic mass of carbon 12 is 12 atomic mass units. That of carbon 13 is 13.003554. The required energy to remove a neutron from C13 if mass of a neutron is this. So you're essentially looking for a mass defect, and as a result of mass defect, the binding energy. So that energy required to take it out is equal to mass of the C13, mass of the C12 plus mass of the neutron minus mass of the C13. That's what we are looking for. Into C square. Into C square. We don't bother too much with the C square if you represent it in atomic mass units. So over here, if we put it on in, we're going to get 12 plus mass of the neutron is 1.008665 minus C13 was 13.003554 into atomic mass unit into C square. So we can write this, you can see this is 13. So technically I am subtracting this 0.008665 with 0.3554. So if I just do it here separately, I'll only look at that part. That's what's important. Oh, so my bad, this is 3354. So if I put 3354 here, then that will come out as 3 here, so 5311. So I'll essentially be having 0.005311. Add this and subtract, you'll get this, into 1 atomic mass unit into c square is equal to 931.5 mega electron volts. Sorry, mega electron volts. So over here you can roughly get a rough idea where it's going to go to. If I have 5 multiplied with 9, then that would take it to somewhere around 45. Take it to somewhere around 45. A bit more than that. So the only possible cases are this or this. Would either be this or this. Now you look at it, if you consider this as 1000. If you consider this at 1000, then you would be bringing it all the way over here. So it would be roughly 5.31. It should be a little less than 5.31. Only possible case is 4.95. That is the answer. Okay. So don't try to go through the entire detailed calculation. Use your approximations there. Next up says a ball is suspended by a string, by a thread, swings in a vertical plane so that its magnitude of acceleration in the extreme position and the lowest position are equal. The angle theta of the thread deflection in the extreme position is going to be how much? So let's visualize what this is going to be like. You have, this is your equilibrium position. Bob is currently over here making an angle theta. It's making an angle theta. So the restoring force or the restoring acceleration, the acceleration it feels at the extreme point is not just going to be the mg here. It is going to be in this direction. The force and correspondingly the acceleration is going to be g sine theta, because that is the acceleration that's pulling it back. The cos theta part is just going, the force of the cos theta is going in balancing the tension. So we don't really require that. Now when it comes down over here, when it's at its mean position, at that point, technically the acceleration only comes from the centripetal acceleration. Centripetal acceleration, whose value over here, let's call it A extreme, is equal to g sine theta, whereas the acceleration at the bottom point AB is v square divided by, if the length is L, let's assume that the length of the string is L, then that also happens to be the radius of the circle traced, so it is v square by L. The centripetal acceleration, that is the only acceleration at the bottom point. So how do I get this v square out? How do I get this v square out? It goes down in height by an amount h, which will equal to L into 1 minus cos theta. I hope you're all familiar with it. Simply it comes from geometry, because this is L cos theta. The entire thing is L. So the gap in height over here is L1 minus cos theta. So from there we know, by equating kinetic with the potential energy, half mv square is equal to mgh. Cancel this out. We get v square is equal to 2g and h is equal to L 1 minus cos theta. So it's all about putting it in here. B is equal to v square, which is 2gl 1 minus cos theta, 1 minus cos theta, divided by the L, take the L's out. So AB is equal to 2g into 1 minus cos theta. So we know what is the acceleration at the bottom point. We know what is the acceleration at the extreme point. The question says that they are equal. They are equal. So AX is equal to AB. Let's put that in. AX is g sine theta and AB is equal to 2g 1 minus cos theta. Take the g's out. So sine theta, let's break it up into 2 sine theta by 2 cos theta by 2. And on the other side, leave the 2 as is. 1 minus cos theta can be written as 2 sine square theta by 2. Cancel out one of the sine thetas by 2. Cancel out one of the 2's. So if I bring the cos theta by 2 down and send the 2 over to that side, I will get tan theta by 2 is equal to half, because this 2 comes down and the cos theta by 2 goes there. So just from there I get theta by 2 is tan inverse of half, or theta is equal to 2 tan inverse of half. So correct answer here is going to be option B. This would be considered the only slightly trickier question in this question paper. Let's move ahead to our next question. It says 3 voltmeters, all having different internal resistances, are joined in the figure. When some potential difference is applied across A and B, the readings are V1, V2 and V3. Choose the correct option. So it's pretty straightforward. You can see it over here that whatever is the potential drop measured across V1, that across V2, and finally you have V3 over here. So of course V1 plus V2 should be equal to V3. It's pretty straightforward over there. Because V3 is measuring the potential drop across these 2 points. V1 and V2 are measuring the potential drop across these points, these points. So total potential drop is V1 plus V2. So that is why they're technically measuring that V1 plus V2 is measuring the same thing about the potentials of A and B. So they are equal. Next up, total kinetic energy of 1 mole of oxygen at 27 degrees Celsius is how much? So over here, this is oxygen. You're looking for the total kinetic energy. So the total kinetic energy for oxygen, which is a diatomic molecule. Oxygen, that's a diatomic molecule, is 5 by 2 nRT. 5 by 2 into the number of moles is 1. So you don't need to bother about that. R is given as 8.31. Into the temperature is 27 degrees Celsius, you have to convert it to 300 Kelvin. If you want to help with your calculations to get to a roughly correct point, you can forget about this 8.31 and instead represent 8.31, represent the universal gas constant as roughly 25 by 3. That's an approximation that you can use. If you do that, take this out. Leaves behind 100, leaves behind a 50. So 5 into 25 is 125, 125 into 50 is going to give you 6250. The only possible options close to it is option C. You can right away mark it over there. Okay. How about the next one? It says given below are 2 statements. One is assertion reasoning. In Vernier caliper, if a positive zero error exists, then while taking the measurements, the reading taken will be more than the actual reading. That is correct, because positive zero error means you're already starting a little before, a little later. So you'll even push a little further on the other side. So you'll get a higher reading. Next, zero error in Vernier caliper might have happened due to manufacturing defect or due to rough handling. This is also a correct statement. Both are correct, but this is not the reasoning for this. So it is going to be option C. Both A and R are correct, but R is not the correct explanation of A, of the assertion statement. Next one says, primary side of a transformer is connected to a 230 volt 50 hertz supply. Turns ratio of the primary to secondary is 10:1. Load resistance connected to the secondary side is 46 ohm. Then what is the power consumed in it going to be? Pretty straightforward. We know voltage in the primary by voltage in the secondary is equal to number of turns in the primary by secondary, which is equal to 10 by 1. So that makes voltage in the secondary is equal to Vp by 10. Vp is 230 divided by the 10. Take this out, so that is 23. Now you want what is the power consumed in the secondary circuit. In the secondary circuit, this is the voltage and this is the RMS voltage, because this is also the RMS voltage provided here. There's only resistance, so you don't need to worry about power factor and everything. You can directly go for the power consumed as V square or Vs square by Rs. Vs we got as 23, so 23 into 23 divided by the resistance is 46 ohm over here. Goes with the 2, 2 goes with the 23 to leave behind 11.5. So it is option C. It is 11.5 over here. Okay. How about we move on to the next one? This one says during an adiabatic process, the pressure of a gas is found to be proportional to the cube of its absolute temperature. the ratio of Cp by Cv for the gases. So this is like a polytropic process. You want to get to that Cp by Cv. You want to get to that gamma in that adiabatic process, right? How do you do it? It is said the pressure is found to be proportional to cube of its absolute temperature. So P is proportional to T cube, or P into T to the power minus 3 is going to be a constant. Pt to the power minus 3 is a constant. I just brought the T cube over to the other side. Now T is equal to PV by Nr. So I can write it P into PV to the power minus 3, PV to the power minus 3 divided by Nr to the power minus 3 is a constant. Now this Nr to the power minus 3 I can cross multiply to the other side because it's a constant, won't play any role here. It's going to go over to the other side. So I will eventually be left P to the power minus 2, V to the power minus 3 is equal to a constant. Because you'll have P to the power minus 3 into P to the power minus 2, that stays V to the power minus 3. So this can be written as P V to the power 3 by 2 is a constant. This is what I needed to get to. P V to the power 3 by 2 is a constant because it's an adiabatic process. I know for an adiabatic process, PV to the power gamma is a constant. By comparing, I can tell that gamma is equal to 3 by 2 for this process, and Cp by Cv happens to be that gamma. So if gamma is 3 by 2, that is our answer. Option B, 3 by 2. Next question says the threshold frequency of a metal with work function of 6.63 electron volts is how much? So threshold frequency over here, the work function is given. So work function phi is equal to H into mu naught. 6.63 electron volts, so 6.63 into 1.6 10 to the power minus 19 is equal to H is equal to 6.63 into 10 to the power minus 34 into the mu naught. Cancel out the 6.63s on both sides. So mu naught comes out to be 1.6 into 10 to the power 15 hertz. Because plus 34 minus 19, that is 15 hertz. So it is option D over here, 1.6 into 10 to the power 15 hertz. Next question says, the assertion, the property of a body by virtue of which it tends to regain its original shape when the external force is removed is elasticity. Yes, that is correct. That is the definition of elasticity. Next, restoring force depends upon the bonded interatomic and intermolecular forces of the solid. That is also correct. But this is not technically the reason. You can consider it. It's a slightly ambiguous thing. You can even call it this. So this is slightly ambiguous. There's a chance of this as bonus question. But we will actually consider it to be the reason for this, because this is the reasoning for that behavior, reasoning for that elastic behavior. So we will opt to go with option C. Next up, when a Polaroid sheet is rotated between two crossed Polaroids, then the transmitted intensity will be maximum for a rotation of how much? So this you can derive, or this is almost a direct theory. I hope you're all familiar with it, that if there are three Polaroids, first and the last one is crossed, means the angle is 90 degree, then the middle Polaroid should be at an angle of 45 degree with both of them to get the maximum intensity out. So you can directly opt for this. This is just one Polaroid. The second Polaroid is kept like this. Third Polaroid is crossed with the first. That's a very direct formula. These angles should be 45 degree. This is Polaroid 1, Polaroid 2, Polaroid 3. So it comes out to be 45 degree. If you do want to derive it, it's pretty straightforward. If a total current of I naught comes in through this, then you, after the second Polaroid, okay, after the first, if an unpolarized light comes of I naught, after the first Polaroid, it becomes I naught by 2. After the second Polaroid, it becomes I naught by 2 cos square theta, if I'm assuming this angle is theta by Malus's law. And after the third one, it becomes I2 cos square into 90 minus theta. So that would make it I naught by 2 sine square theta, which is this cos square 90 minus theta is sine square theta, into cos square theta. Multiply a 4 in the denominator and the 4 in the numerator, you get I naught by 8 into sine 2 theta whole square. So for the final transmitted light to be maximum, you want sine 2 theta to be maximum. For sine 2 theta to be maximum, 2 theta should be 90 degrees, so theta should be 45 degrees. That is how you get it. Next one says an object is placed in a medium of refractive index 3. An electromagnetic wave of intensity 6 into 10 to the power 8 watt per meter square falls normally on the object and it is absorbed completely. The radiation pressure of the object is going to be what? So this is a direct formula for radiation pressure for a perfectly absorbed electromagnetic wave. It is just intensity by the speed of light, 6 into 10 to the power 8 divided by the speed of light, 3 into 10 to the power 8. Cancel it out. So it is 2 Newton per meter square. Next question. Two statements. One is labeled as assertion. So first one, work done by electric field on a moving positive charge on an equipotential surface is always 0. That is true because it is an equipotential surface. So the potential is same at all points. Second, electric lines of force are always perpendicular to the equipotential surface. This is also correct, and technically this is the reasoning for option A. This is because if electric field lines are perpendicular to the equipotential surfaces, as you move on them, forces are always perpendicular to displacements. If the forces, the force will be along the line of the electric field. If they are always perpendicular to the distance or displacement, then work done would be 0. So we would go for option A. Next question says a heavy iron bar weight of 12 kg is having its one end on the ground and the other on the shoulder of a man. The rod makes an angle of 60 degrees with the horizontal. What is the weight experienced by the man? So understand the picture here. This is your ground level. This is suppose the man standing over here. This is the rod. Now over here, the weight of the rod acts straight down, mg. This angle is said to be 60 degrees. Okay. And this person exerts a force of normal reaction here, and that is what we need to find, because that is also the weight that the rod is exerting on the man. It's just the reaction force to that. Now the way you proceed with this is by equating torque, because this is in rotational equilibrium. So the torque about, let's say, this fixed point should be the same. Clockwise torque should be equal to the anti-clockwise torque. What is the clockwise torque? You have a force of mg. This length is L by 2. Force of mg into L by 2 into cos 60. Why cos 60? Because the perpendicular distance between the line of action of that force and the fulcrum is L by 2 cos 60. And that has to be equal to the reverse torque, the counter torque applied by this normal reaction force N, which is at a perpendicular distance of L from the fulcrum, and it is already perpendicular. So you don't need to worry about, you can directly do it as N into L. These L's will cancel out. So your normal reaction force N becomes equal to mg by 2 into cos of 60 is another half. M is 12 kg, right? You want to see what is the weight experience. So 12 divided by 4 into g, that is 6. So it experiences the same weight as, 12 by 4 is 3, my bad. Experiences the same weight as 3 kg. That is the answer for this. You have to go by torque. Don't directly go for the linear case of forces balancing there. Next question says, a bullet is fired into a fixed target, loses 1/3 of its velocity after traveling 4 cm. It penetrates further d into 10 to the power minus 3 meter before coming to rest. What is the value of d? So over here, what you can do, that 1/3 of it is done after traveling 4 cm. Then how penetrates how much further after traveling this entire thing. So over here, let's assume this is the entire path. This is the entire path if it crosses the entire thing. So firstly, velocity goes from initial velocity of v to maybe at some point velocity becomes, it drops to 1/3, loses 1/3. Loses 1/3 means velocity becomes 2v by 3. And the distance there is 4 centimeter. Distance there is 4 centimeter. So we can use v square is equal to u square minus 2as relation. V square, so we get a is equal to v square minus u square divided by 2a. So we will have v square, or rather u square minus v square. This is the initial speed v square minus 2v by 3 whole square, which is 4v square by 9 divided by 2 into, this is 2s, my bad. The distance travelled is 4 centimeter. So we'll keep it in centimeters because at the end I believe we can answer in centimeters only. We'll keep it as 4. So what do we get out? We get 5v square by 9 into 8. That we get as the acceleration. Leave it at that. Now you want to find how much distance, how much further does it travel in order to come to rest. So it's already starting, then you can think over here, suppose it stops here. So its initial speed now becomes 2v by 3 and its final speed here becomes 0. So again, we can go by the relation u square minus v square divided by 2a is equal to s. So what was u? U was 2v by 3 whole square minus v2. It finally stops. So it is 0 square divided by 2 into 5v square by 9 into 8. That is the distance travelled. So what do we get over here? We get 4v square by 9 into 10v square into 9 into 8. That is s. Cancel out the 9s. And what else do we get? 4 into 8 is 32. So the v squares also cancel out. So 32 by 10. So 3.2. 3.2, this would be in centimeters. So it moves 3.2 centimeters. So I believe the only possible case is this 3. Even though I believe you should get a bonus marks here if these were the options. Otherwise it would be 3.2. Actual exact distance it travels is 3.2 before it comes to rest. 3.2 after this point on. So total distance it travels before coming to rest is 7.2. Next we have some numerical answer type question. Let's try this one. It says magnetic field at the center of a wire loop formed by two semicircular wires. Radii R1 is 2 pi meter and R2 is 4 pi meter. Carrying currents 4 ampere as shown over here is alpha into 10 to the power minus 7. Then the value of alpha is how much? So the current is going through this path and through here, back here. There is no contribution to magnetic field from this straight wire and this straight wire because they are in line with the point. They are in line with the point. You mainly want the magnetic field effect because of the upper semicircle and the lower semicircle. And both of them, if you apply the right hand thumb rule, both of them point inwards. Both of them point inwards over there. So that is why we'll just be adding up the magnetic fields. So the net magnetic field becomes, for the, it's just B1 plus B2. B1 would be magnetic field from this R1, B2 would be for this R2. So it is mu naught I divided by 4R. 4R, it's generally 2R, but because these are semicircles, we'd go by 4R. So 4R1 plus mu naught I by 4R2. So over here, what do we get? We get mu naught is 4 pi 10 to the power minus 7 into the current. Current was given as 4 amperes divided by 4R1. So 4 into R1 is provided as 2 pi minus, plus mu naught I, which is again 4 pi into 10 to the power minus 7. Current is 4 amperes divided by 4 into R2 is 4 pi. So cancel this 4 pi here. Cancel this 4 pi here. So this here leaves behind a 2. This goes here. So we have 10 to the 2 into 10 to the power minus 7 plus 10 to the power minus 7, which would make it 3 into 10 to the power minus 7. So alpha is equal to 3. That is the answer. 3 is the answer for this question. Let's move to our next question. This says two charges of 4 microcoulomb, of minus 4 microcoulomb and plus 4 microcoulomb placed at the points 1,04, B 2 minus 1 5, located at the electric field E is equal to 0.2 I cap, so on and so forth. Magnitude of torque acting on the dipole is 8 alpha into 10 to the power minus 5. So we know dipole moment is equal to Q into L, right? Q into L, the charges into the distance between the charges. Now this as a vector form can be written. So for our case, here is where the negative charges and here the positive charges. So vector should point from negative to positive charge, the dipole moment. So we will get charge is 4 microcoulomb, so 4 into 10 to the power minus 6 into this vector minus this vector, because you are taking displacement vector from here to here. So we will get 2 minus 1 I cap, the I cap vector subtracted, plus minus 1 minus 0 j cap, plus 5 minus 4 k cap. So what do we get as a result? We get P vector is 4 into 10 to the power minus 6 into I cap minus j cap plus k cap. That is your dipole moment vector. Your electric field vector is also given as 0.2 I cap, and we know torque as a vector is P vector cross E vector. So let's do the cross product of that. P is what? 4 into 10 to the power minus 6. And let's even take the magnitude of the electric field out as 0.2. In the cross product part, j cap, k cap. In that cross product part, we have P vector is 1 minus 1 and 1. And in the other one, we have, it is just I cap, so 1 0 0. Already I've taken the 0.2 out. So what do we get? We get this as 8 into 10 to the power minus 7. And from here, what do you get? I cap is 0, because this is 0, this is 0. J cap minus j cap, 0 minus, so this is 0 minus of 1, plus k cap into 0 minus of minus 1, because minus 1 into this 1. So this is my torque vector. So what do we get? This is j cap plus k cap. So in terms of its magnitude, j cap plus k cap will just give me a root 2 out for its magnitude into 10 to the power minus 7. So we have, oops, where did we miss out? Oh, this was given per centimeter. Which means at some point we would have had to multiply this with 100. So that would make it 10 to the power minus 5. So 8 root 2, 10 to the power minus 5. We had to represent it as, we need to find this alpha. So alpha is equal to 2. That is the answer. Let's move ahead to our next question then. It says a closed organ pipe 150 centimeter long gives 7 beats per second with an open organ pipe of length 350 centimeter. Both are vibrating in the fundamental mode. The velocity of the sound is, I believe the answer has also been given here somehow. So we'll solve it anyway for this. So what is the formula for the fundamental mode of a closed organ pipe? It is V by 4L. V by 4L. And what is that for a open organ pipe? It is V by 2L. Right? It is V by 2L. So V by 2 into open organ pipe, length of the open organ pipe, and the difference in those frequencies is 7, because that is why we hear the 7 beats per second, the difference in frequencies. So frequency of this minus frequency of that one. Let's put it in. V divided by 4 into 150 centimeters. So 0.15, or sorry, 1.5, it's in centimeters. 4 into 1.5 minus V divided by 2 into 3.5. That is equal to 7. So if I can write it as V by 6 minus V by 7, because it was a 2 into 3.5, that is equal to 7. So V is 1 by 6 minus 1 by 7, so 7 minus 6 by 7 into 6. This is equal to 1. So V comes out to be 7 into 42. 7 into 6 is 42. That is 294. So yes, this is your answer. The velocity is 294 meters per second. Next question says a body falling under gravity covers 2 points A and B separated by 80 meter in 2 seconds. The distance of the upper point from the starting point in meters is how much? So let's say that it falls over here, and in the next, after 2 seconds, it falls another 80 meters. Let's say that the time till here was t. Then the time when it reaches here is going to be t plus 2. The time till here was t, then it reaches t plus 2. They are asking the distance of the upper point from the starting point. So they are asking for this distance. How do you do it? See, the distance traveled in this, it's released from rest. So u initial speed is 0. So that S1, let's call this ST, and let's call this S of t plus 2. So total distance traveled in t plus 2 seconds, total distance traveled in this. So the 80 meter is technically S of t plus 2 minus S of t, distance traveled in t seconds. So 80 is equal to half g into t plus 2 whole square minus half gt square, right? Because it is technically ut plus half gt square released from rest, so u is 0. So we can directly do half gt square for each of them. So 80 is equal to half gt square plus half g into 4t plus half g into 2 square, which is 4 minus half gt square. Cancel the half gt square. I just opened it up as a plus b whole square. So a square, so half gt square, that one, plus 2ab, so 2 into t, that is 4t, that is why multiplied with 40. Half g is already out. And lastly, b square, so half g, and this b square, this 4 over here. So over here, what do we get? Half g is there, so I can directly put g is equal to 10, right? I can directly put g equal to 10, remove them to get this out. Cross multiply the 2 to get 16. Cross multiply the 2 from both of them to get 16 is equal to 40 plus 4. 40 plus 4. So if you solve for this, 40 will be equal to 12. So t will be equal to 3 seconds. So we have found how long it falls before we start measuring that 80 meter. Now we just want this st, which is half gt square, and t value we have got as 3 seconds. So st, what we require, half gt square, which is half into 10 into 3 square. So 5 into 3 square is 9. So 5 into 9 is 45. It is 45 meters. That is the answer for this question. Next question says, the reading of the pressure meter attached with a closed pipe is 4.5 into 10 to the power 4 Newton per meter square. On opening the valve, water starts flowing and the reading of the pressure falls to 2 into 10 to the power 4 Newton per meter square. The velocity of the water is found to be root v meters per second. What is the value of v? The value of that v is. So this is simple Bernoulli's theorem. They are at the same horizontal level. So technically I can write P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Initial case, the pressure was this, and it was closed, so velocity was 0. So 4.5 10 to the power 4 plus 0, because initial velocity was 0, that is equal to P2. In the second case, it is 2 into 10 to the power 4 plus half rho. This is water, right? This is water, so it's 1000 kg per meter cube into the V square. That is what we want. That velocity is what we want. So what do I get if I shift it here? I get 2.5 into 10 to the power 4 is equal to half 1000 into V square. Cross multiply this, first take this out. 2 into 2.5 would be 5, 5 into 10 would be 50, so V should be equal to root over of 50 meters per second. So the value of V is 50. We have to represent the velocity in terms of root over of capital V. So that is 50, because it is root over of 50 here. That is the velocity. Okay. So I'll just box it up. So this becomes clear what the answer is. So let's move to our next question. This says a ring and a solid sphere roll down the same inclined plane without slipping. They start from rest, radii of both bodies identical, ratio of their kinetic energy is how much? Now you might think you'll have to worry about the radius of gyration and how much portion is given to rotational translation. Don't have to worry about anything, because at the end of the day, they are both rolling down by the same height. So the kinetic energy they will have, the total kinetic energy, the translational plus rotational, will be the same for both of them. So that is why x value, the ratio between them is going to be 1, because they have said kinetic energy, not translational or rotational. So kinetic energy, total kinetic energy would be the same. It would technically be equal to this mgh. So x is equal to 7, because the ratio has to be 1:1. Next question says a parallel beam of monochromatic light, wavelength 5000 Armstrong, is incident normally on a single narrow slit of width 0.001 millimeter. Light is focused by a convex lens on a screen placed on the focal plane. First minima will be formed for the angle of diffraction of how much? So minima positions we know directly. For the first minima, A sin theta is equal to lambda. It's m lambda, but since the first minima, so m is equal to 1. So sin theta is equal to lambda by A. Lambda is 5000 Armstrong, that is 5 into 10 to the power minus 7, divided by 0.001 millimeter. If you put that in, you will see that is equal to 10 into 10 to the power minus 7 in meters. Okay, I'll write the units also meters so that you're not confused. 10 to the power minus 7 cancels out, this cancels out with the 2. Sin theta is equal to half, so theta will be equal to 30 degree. That is your answer for this question. Next one says electric potential at the surface of an atomic nucleus of Z is equal to 50 into radius 10 of radius, this 10 to the power minus 13 centimeter is how much? So over here we have the potential formula is technically kq by r on the surface of any spherical body. K is 9 into 10 to the power 9. Q is the charge, that is Z into E, so Z is 50. Charge of an electron is 1.6 into 10 to the power minus 19. ZE divided by R, the radius is given 9 into 10 to the power minus 13 centimeter, which means 10 to the power minus 15 meters. Take the 9s out, remove the meters here. Over here, it will leave behind a 10 to the power minus 4, that leaving behind a 10 to the power 5. So we have 15 to 1.6, that is 80 into 10 to the power 5. We have to represent it in terms of 10 to the power 6, that is 8 into 10 to the power 6, which means our answer here is 8. That is the answer for this question. Next question says if Rydberg's constant is R, the longest wavelength of radiation in the Paschen series will be alpha by 7r, where alpha is equal to how much? So Paschen series means it goes from n equal to 3 to the higher orbits. Now for the maximum wavelength, we want the longest wavelength, so it has to make the nearest jump. So from 3 to 4, that's the nearest jump it will make for the longest wavelength. So we know 1 by lambda is Rydberg's constant to 1 by n1 square minus n2 square. For the maximum wavelength of the Paschen series, so the nearest one is 3, so it has to be from 3 onwards, 3 square minus the nearest one is 4 square. So that is R into 1 by 9 minus 1 by 16. That makes this R into 16 minus 9, that is 7, divided by 16 into 9, that is 144. So 1 by lambda is this. So lambda is 144 by 7R. So alpha over here is 144. That is the answer for this question. Next one says a series LCR circuit with L is equal to 100 pi millihenry. Capacitance is this and resistance is 10 ohms connected across an AC source of 220 volts 50 hertz supply. The power factor of the circuit is going to be what? So we have the frequency. First and foremost, let's try to find what is the inductive reactance and the capacitive reactance. Inductive reactance XL is equal to omega L, which is 2 pi FL, 2 pi into 50 into L is 100 by pi. Cancel this out. So it is 100 into 100, that is 10 to the power 4. That is the inductive reactance. Okay, this is given in millihenry. My bad, this was given in millihenry. So there's a 10 to the power minus 3 as well, which will make it just 10 ohms. It will make it just 10 ohms. What about the capacitive reactance? Capacitive reactance is 1 by omega C. That is 1 by 2 pi F into C. 2 pi, frequency is 50. And the capacitance is 10 to the power minus 3 by pi. Pi, cancel the pi's out. So 100 into 10 to the power minus 3 will make it 1 by 10. 1 by 10 to the power minus 1. This will also come out to be 10 ohms. So you see XL is equal to XC, which means this setup is in resonance. If it is in resonance, then we know in resonance, power factor is always equal to 1. So the answer is going to be 1 over here. Alright. So I believe that was the last question we had for the 27 Jan shift 2. We will also be getting the following shifts as well. So stay tuned to Infinity Learn by Sri Chaitanya. I'm your teacher today, physics teacher today, Mritunjaya Sir. Thank you all so much for tuning in. Catch you all again in the next one.